Your team ships a redesign. The homepage loads in about 2 seconds, everybody screenshots the score, and the project channel gets a rocket emoji. 6 months later, the same page takes almost 5 seconds, and the first person to notice is a customer. So now there's a meeting, and somebody in that meeting asks why QA didn't catch it. That question is fair. Speed is a quality attribute. We test whether login still works after every change. Almost nobody tests whether the page got slower. So in this video, let's fix that properly. You'll walk away with 3 things. The exact numbers Google uses to define a fast page as of this recording, the difference between the numbers your laptop gives you and the numbers your users actually feel, and a way to wire a speed budget into your pipeline so a slow pull request fails the build just like a failing test would. That last part is the piece most teams never build. Alright, so now let's look into the numbers. Google calls them core web vitals, and there are 3 checks on the user experience. Largest contentful paint is loading. How long until the biggest thing on screen, usually your hero image, actually shows up? Good means 2.5 seconds or less. Interaction to next paint is responsiveness. You tap a button, how long before the page visibly reacts? Good means 200 milliseconds or less. And cumulative layout shift is stability. That's the page jumping around while you're trying to tap something. Good means 0.1 or less. Now here comes the part most people miss. These thresholds are not about your average visit. Google measures at the 75th percentile split across mobile and desktop. So imagine lining up 100 real page loads from fastest to slowest. Visitor number 75 has to be inside the threshold. Your median can look great while a quarter of your users are having a bad day. And that quarter is usually on a mid-range phone, on mobile data, nowhere near your office Wi-Fi. Which brings us to the trap. When you run Lighthouse on your machine, that's lab data. One synthetic visit from developer hardware on office internet. Really handy for debugging and completely capable of lying to you about real users. Field data is the opposite. Google collects it from actual Chrome users and publishes it as the Chrome UX report. That's what the ranking systems care about. So the rule is simple. Field data tells you whether you have a problem. Lab data helps you find it. You need both, and you should never quote one as the other. Coming back to why I picked this topic. Webflow has a popular guide on improving website performance. The advice in it is fine. Compress your images, cut third-party scripts, cache properly. But look at its measurement section. It lists the top 3 metrics to monitor as LCP, TTFB, and INP. Google's own documentation says TTFB is not a core web vital. And the actual third vital, layout stability, does not appear in the post at all. The article that tells you how to get faster never quite tells you what parsing looks like. For us, parsing is the entire job. To be fair to TTFB, it's not a useless number. It measures how long the server takes to send the first byte back. Google suggests keeping it under roughly 800 milliseconds as of this recording. But it's a diagnostic, not a verdict. If LCP is slow, TTFB tells you whether to blame the server or everything after it. Nobody's user experience ends at the first byte, so keep it on the dashboard. Just don't let it replace a vital that actually watches the screen. Alright, so now let's turn measurement into enforcement. The tool for this is called a performance budget. A budget is an assertion about the page. The same way a test asserts that login succeeds, a budget asserts that LCP stays under 2.5 seconds. Google ships an open source runner for this called Lighthouse CI. You give it your URLs and your thresholds, and it runs Lighthouse on every pull request. If a change blows the budget, the check goes red, and the pull request tells the developer, hey, this made the page slower. And this is the moment the whole video is about. A developer adds an auto-playing hero video. Functionally, everything passes, but the performance check comes back red. LCP 3.4 seconds against a budget of 2.5. The conversation happens in the pull request. before the slow page ever meets a customer. That's the difference between improving performance and testing it. One is a launch week activity, the other is a regression suite. And regressions are our home turf. One honest warning before you go set this up. The CI gate runs lab data, so it inherits lab blindness. It will not see the marketing tag that only loads in production, and it will not feel the mid-range Android experience. Lab numbers also wobble between runs, so run Lighthouse a few times and assert on the median the same way you'd handle any flaky test. The gate is there to stop regressions from merging, and the field data is there to keep you honest. Check it monthly. So in a nutshell, speed is a quality attribute with 3 published thresholds. Real users at the 75th percentile decide pass or fail, not your laptop. And a budget in CI turns all of it into a test that runs on every change. Give it a try on one page this week. Your slowest important page is the right place to start. Now I'm curious about your setup. Does your pipeline have any speed check at all? Or does performance still live on a launch checklist? Tell me in the comments. Alright, so that's all for this video, and I will see you in the next.